So, good day class, my name is Norman and I'll be your instructor for statics of rigid bodies, and this is a recap lang ng lecture 2 ng force vectors natin. So, to purpose why I did this pre-recorded session for those who already had yung lesson na to and for those who are about to having a lesson na to. So at least dito pwede nyo masabayan, at least I'm teaching you face to face, and we'll go through yung concepts and yung sample problems natin one by one. Not sure kung makaya ko include pa later, maybe even problem sets, but that will be in a separate pre-recorded video na lang. Okay? And with that, let's start with the lesson. So, what to expect pagdating sa lecture 2? So, we have yung scalars and vectors, yung definitions nun, kind of operations that we do, what are the typical problems na meron tayo, and of course doing some operations on forces on the same plane, that is in coplanar force systems. What does it look like and how do we operate in it? And then of course we are gonna dig deeper ng konti pagdating sa Cartesian vectors. So if you're familiar with your rectangular coordinate system, this time we're gonna be using a different notation using unit vectors. We're gonna assign letters for yung direction ng force vector nyo. More on that later. Then of course, we're gonna go with yung 3D. We're gonna do the same thing. So we have yung scalar operations rin dun. And of course, yung Cartesian vector notation rin dun, pero in 3 dimensionals. And lastly, we have last 2 points will be yung position vectors and yung dot product. The thing naman dito, for position vectors, force is not the only vector available here. We also have displacement. We also have in direction. We also have in coordinates. This is a scenario wherein you're not given an angle and you're not given a force, but instead you're given the position, the physical position of the force itself, like how far it is from the origin. More on that later. And then dot product is one of its applications done. Basically, dot product lang naman is simply the product of two forces in between, two force vectors in between an angle. Okay. Let's go with 1 and 2 first. So scalars and vectors, when it comes to measuring in engineering, we measure physical quantities using scalars or vectors. Definition of scalars is here. It's usually specified as either positive or negative in quantity and is specified by its magnitude. Examples of it are length, time, mass, and temperature. Vectors, on the other hand, require both magnitude and direction. Physical quantities such as displacement, force, torque, and velocities, those are just one of the examples. And graphically, you'd see it as an arrow with point origin along its line of action. The length of the arrow indicates the magnitude, the tail, the tip represents the sense of direction, and the angle between the vector and axis represents the direction of its line of action, basing it from a positive or whichever axis it represents. Okay? For our purposes, you would notice in our module and the books, those in bold-faced letters are classified as vectors. Those in italics are scalars, just for distinction. But since we're gonna be solving by hand most of the time, if the one with the letter with an arrow will be your vectors, the one without an arrow will be your scalar or your magnitude mo. Okay? Now, to make sense of the direction, to make sense of the magnitude and direction of the vectors in our world, we use yung Cartesian rectangular coordinate system natin. Okay? Sometimes we also use a polar coordinate system, which we'll be using most of the time. And the relationship between two coordinates can be explained using yung definitions ng Pythagorean theorem, just like the one drawing you saw here. Remember, so if you have a rough time with your trigonometry or basic geometry, I suggest you do a quick recap and to make sure your fundamentals and basics are intact. Here in our lecture, we'll be using another notation, which is in Cartesian Vector Notation nga, wherein we're assigning unit vectors sa mga force vectors natin. What does it entail? Essentially, may kapartner lang yung iniwalay lang natin si magnitude and yung direction. Kasi pag scalar notation, usually kasama yung magnitude and yung sign niya, like yung kung positive siya or negative. In this case, we assign yung kung positive ba siya or negative with letters such as I and J. I sa x-axis and J sa y-axis. Where I and J are unit vectors in which it has a magnitude of 1. Okay, for vector operations, say we have a vector A dito. Okay, you multiply a vector, you increase yung size ng kanyang arrow or kanyang body graphically. So it will be 2A. You multiply by a negative number, you simply reverse its direction. You divide it by half, you simply half the size ng kanyang magnitude. And still keeps you in the same direction niya. So for vector addition, for example, if you have two vectors and a common origin point, you can actually project them by using the parallelogram law of addition to project where your resultant force would be. Just like so. And then from here, you can actually use yung triangle rule or tip-to-tail method to access better quality equations concerning triangles. So tip-to-tail method, at the end of the vector A, you could connect the vector B, and you connect the endpoints. So from the tip of A to the head of final vector B. And the summation of the resultant force here is equal to the summation of vector forces A and B dito. So in this case, this vector force R, ang components niya ay A and B. Force vector components niya ay A and B. Now for vector subtraction, it just means that one vector is in the opposing direction lang ng pagdating sa rectangular coordinate system natin. In this case, vector A here is in the first quadrant, vector B here passes through yung second quadrant where yung x-axis natin is negative. From here, we can also use yung parallelogram law of addition to project where our resultant force is. And we would still arrive at the same conclusion. Technically, you can do this as R equals vector A plus negative vector B. So, mawawala yung plus sign dun kasi negative na si B eh. You can also use yung tip-to-tail method and you would still yield the same equation rin. Now, to help you further with vector force operations, there are two kinds of problem usually provided. Either you are finding the resultant force using its known components or knowing the components using yung resultant force. So either you have already yung you already have two vector force components to find yung resultant force, or you're supposed to look for yung vector force components using yung resultant vector. To help you further solve yun, we will add on top of our parallelogram law of addition and triangle rule yung law of cosines and sines, which is indicated here. So where C is equals to square root of A squared plus B squared minus 2AB cosine C. And then yung law of sines naman is simply yung relationship ng sines and yung angles nila on the sine function. So A over sine A, B over sine B, and C over sine C. Now take note, pagdating sa law of cosines, you can also interchange this. For example, if you already have C, you have A, you can actually solve for B rin. And you have angle, if you have yung opposite angle ng side B, you can use yung law of cosines rin to solve for side B. Let me just show an example. You can interchange. For example, you're looking for B, and you have yung angle nan, and you have C and A. You can also write the equation just like so. A squared minus 2ac. Then cosine b, same. If you're looking for a, magiging b squared, c squared, 2bc cosine a. If you're still curious kung paano naging ganyan yung law of cosine, paano naging law of sines, you can quickly Google search how to derive law of cosines and sines, and you will be shown a lot of results for using basic Pythagorean theorem and using yung trigonometric fraction to get yung equation na yan. Okay? And to give you a head start, you can start by dividing this, giving it an altitude. And you try to get yung sine, and yung cosine function nila. Accordingly, magkakaroon kayo ng common term, which is h, and you just simply substitute it lang. And you would yield with this particular equations, regardless of what you start here. Okay? Okay. Para magkaroon tayo ng memory recall, let's try to give it a practice run. Okay, here we have an example 2.1 from page 23. There is a screw I below subjected to two forces F1 and F2. We are to determine the magnitude and the direction of the resultant force. Okay, so we're given F1 and F2 and we are to find the magnitude and direction. And if it's not mentioned here, always assume it is from the positive x-axis. Okay, the direction from the x-axis for the resultant force. We can start by actually drawing it first. We have F1 at 100 newtons. And it's 15 degrees above the x-axis. And we have F2, which is 150 newtons, which is 10 degrees from the positive y-axis. From here, we can actually see this is the kind of problem where we have two forces and we're being asked what the resultant force is, where the resultant force would be. We can estimate that by by using our parallelogram law of addition to project where our resultant force, and by connecting the intersection points on the origin and the projected parallel points. There we are. And then from here, we can now convert it. We can use our tip-to-tail method to make use of our equations ng cosine law and ng sine law. So for here, we understand to get FR, for us to use yung FR, we know that we have to get yung opposite angle niya. We only have yung 15 degrees dito. We only have yung 15 degrees dito. Let me change yung color niya para maiba. Yeah, there we go. Let me just erase this lang muna. There we go. So let's go with red. So to expound it, to get this, kung magtataka bakit may 115 dito, we're able to obtain it using yung 15 and yung 10 degrees. How? So if you're familiar, if you recall your trigonometry, yung properties ng angles niya, especially with parallel lines, you'd get this one. So then may x dito. We have yung y natin dito. And then we have another angle dito. There we go. And then just assume that this is yung n ng F2. And so let's start with yung 10 degrees. We know very well that this is 10 degrees. Based from this angle, if you extend it all the way down. Kasi pag in-extend mo dito, this is also 10 degrees, same as this given here. You assume, so you put here 10 degrees. This one naman, alam mong 15 degrees siya. Yung opposite angle niya is 15 degrees, which would leave you 90 degrees. So yung total angle nito is 90 plus 10 plus 15 is equals to 115 degrees. Okay? And from there, you can apply na yung cosine law to solve yung force resultant mo, yung magnitude at least. Okay? Also, bear in mind, yung direction ng force natin is from the positive x-axis. Hence, naglagay pa tayo ng isa pang variable na isa pang angle dito na angle phi, where pag nakuha na natin yung angle theta, we just simply add yung 15 degrees to get yung final direction ng resultant force natin. So when we apply yung cosine law, we will get this one. Fr is equals to the square root, the sums ng squares ng 100 plus 150 minus the product ng 2, 100, 150, and cosine 115 degrees. And we get 212.55 or 213 newtons. That's one. Next one dito, para makuha naman natin yung angle theta, we just simply use yung sine law. And we will get 39.762. And to get yung final direction ng magnitude natin from the positive x-axis, we will have yung 55.8 degrees. But that's from the book eh. So my answer here is, sa ground off ako, that's gonna be 39.762 plus 15. That'll be 54.672. Degrees. Okay. Let's try another problem naman. This time, available yung would-be resultant force. And we're finding yung components ng forces niya along the U and V axis named as such. So, meron tayo dito. So, meron chain dito, merong force na humihila dito, and then we're being asked ano yung components under the U and V axis that provides yung 600-pound force na to. Okay? So we are to ask yung, ang ask natin is determine the magnitude of these components. So we are asked to find yung FU and FV. To make sense of things, we are supposed to, it's always easier to understand yung problem when you draw the diagram yourself. So you have here yung representation ng drawing. So ito yung arm na yun. This would represent yung V later. Then you would add muna yung 600-pound force mo. You know na it's acting, you know, it's resolved the horizontal 600-pound force, and it says here positive. It didn't say naman negative. So 600-pound force, nakalagay dyan. Then from here, you can add yung U and yung FV mo, just like so. Kasi sabi, they are acting down on the U and V axis. Now, it doesn't matter kung ano yung, kung gaano kahaba sila or not, since hindi naman naka-indicate. But we do know na arbitrarily, it represents, it might look like just like this graph dito na ginawa natin. Okay? You just have to use a little bit of imagination ng konti. Okay? And in this case, doesn't need much of imagination kasi I just kind of scale lang naman whatever yung 600-pound force dito and then try to draw it from there. Okay? After all, ang kailangan mo force lang naman dito. Force vector. And then we add yung degrees nila. We know that this is 30 degrees. And another one 30 degrees. And then from here, you can actually project na using yung parallelogram law of addition. So if parang we're doing it in reverse naman, instead of projecting where the resultant force is, we're trying to project where it could possibly be. So we made a reference from our 600-pound force, and then from there, technically pwedeng lumampas to. Pero from here, we figured na it could be na hanggang ganito lang yung magnitude ng force vector U, and then hanggang ganito lang yung magnitude ng force vector V. Tapos from here, we can figure out na several angles. First is yung 30. Kung makita mo, parallel to. So, reverse angle lang naman to. Opposite angle theorem. So, we got 30 degrees dito, 30 degrees. By the way, I forgot the official term yun, pero it just sounds, pero it's intuitive enough for me to know na when I see two parallel lines that was intersected by a line, merong angles, they form an angle, and they should be similar. Okay? And then from here, madali na lang yung 120 kasi 120 is simply 180 minus 30 minus 30. So you got 120 degrees dito. From here on out, you can now arrange them using yung triangle rule or tip to tail method naman. So you can start with yung force U dito. And then kunin mo to dito at the edge. So magkakaroon ng force V. Okay, force vector V. And then dugtong mo lang yung 600 pound force dito. And of course, lipat mo lang ulit yung mga angles mo. So from here out, meron tayong two unknowns. Pero meron na tayong given na 600 pound force. Meron tayong angles. So based on our latest information na pwede natin gamitin formula, pwede natin gamitin is yung sine law. Okay? Now, if you ask me kung gagamitin mo sanay kayo sa scalar notation, sir, paano po ba kung pwede natin gamitin yung x forces and y forces? Sure, you can. Pero why would you spend enough time knowing na you can apply a much more simpler explanation naman dun? Okay? Normally, sure, it could work pag two vector forces lang pinag-uusapan natin and a resultant force. Pero what if it's more than 3 na? What is more than 2 pala? 3, 4. Okay, now we move forward. Now we're gonna talk about vector force operations, and possibly more than 2 force vectors. So we show them. Ito yung most likely baka alam nyo, yung scalar notation, wherein you're shown yung force vector F, and per force vector, it has components. Ang tawag doon ng rectangular components niya. In this case, meron siya yung x and y components, so f of x and f of y. F of x is yung horizontal component. In this case, using trigonometric function, Pythagorean theorem, trigonometry, you just f of x equals to f cosine theta, and then fy is simply f sine theta. And if you can see it, you can use yung parallel law of addition, where simply the summation ng vector force f is the summation ng x and y vector components niya. Okay? Now, ganun rin siya, just in case binigyan lang kayo ng slope triangle, which is given as CAB, or CBA. And yung equivalent na cosine equivalent niya, or sine equivalent, you just have to follow it through lang naman rin. For example, f of x is simply f a over c. And dito naman, fy is simply f b over c. Okay? Please recall your trigonometry. Okay? Yung basic functions nun and yung mga basic functions and operations nun, how they operate. So you would notice dito nasa positive fx, yung function, yung force vector x natin ay nasa positive x-axis. Yung force vector y natin, yung y component is nasa positive y-axis. In this case, parehas silang positive. Pero if you were to add them now using this graph, magiging negative yung fy natin kasi it's in the opposite, it's in the negative y-axis na. Okay? Another way to write naman yung vector force operation natin is in yung Cartesian Vector Notation natin, wherein we are assigning I and j as in unit vectors, where I and j holds yung whether positive or negative sila. So in this case, pareha silang positive kasi nasa positive axis yung x and y natin. Okay? Pinagkaiba lang naman with scalar, in this case, kung gagamitin natin to, sabihin natin, so force vector nan is simply summation ng force vector x plus negative y, kasi pababa yung y. Okay? Makikita mo pag sa scalar notation siya, it holds both yung magnitude and in direction kaagad. Okay? Kasi indicate mo agad yung sign. Wherein pag Cartesian vector notation, yung in this case, si j yung nasa negative side dito, sa negative j dito. Ito yung positive j. Ito yung I. Lahat yan. Okay? So, ang gagawin natin yan to yung vector notation. Pag sinabi kong convert into Cartesian vector notation, ang mangyayari lang naman ganito. Iiwalayin mo na hindi na siya vector. Yung f of x mo na yan dyan is just simply a magnitude. Pero katabi niya na yung unit vector I. In this case, positive kasi nasa positive x-axis tayo. Now, for the y component naman, technically, pag di ko siya sinimplify, ganito siya. So, wala na yung arrow niya. Pero yung j niya is negative j. Pero we can just, shortcut it and just put it diretso na alam natin na negative yun. Kasi nasa negative y-axis naman siya. Indicated by J. Okay, since yun yung unit vector niya. Okay? So again, yung ing just simply points out na kumbaga dinelegate lang ng vector fx and fy yung kanyang positive or negative sign sa letters I and j. And later, pag 3-dimension, magkakaroon tayo na isa pang letter which is say, but more on that later. So before that, let me try to explain na what if there's more than 2 vectors naman? What if there's 3? So, what if there's 3? Ang mangyayari naman dyan, per vector, remember, meron silang x and y components dyan. So, yung force 1 vector mo has its own, and force 2 has its own x and y components just like so. So, meron siyang f1, force 1 sub x, f1 y component. Yung f2 meron siyang x and y component. Yung force 3 mo has yung x and y component. If you recall yung quadrants natin, we know na dito is always positive. Huh? This is negative, positive. This is negative, negative. This one is positive, negative. Okay? So, of course, for scalar notation, ang mangyayari lang naman, summation, all you have to do lang, ganun pa rin naman. You have to sum of all the x and y components ng resultant force mo. So, yung resultant, the resultant x forces, kailangan mo i-sum yun. Yung resultant y component mo, kailangan mo i-sum yun. And once you got that, you can now get na yung magnitude ng FR via Pythagorean theorem. And you can also get yung angle niya via getting the tangent theta or inverse tangent theta and then y over x dito. Okay? The first clue mo kung saan manggagaling yung theta mo, kasi sometimes pwedeng negative dito, hindi mo siya absolute value. Or in this case naman, pareha silang negative. Yung isa naman dyan, possibly na negative yung isa. So, yun yung first clue mo kung saan siya manggagaling side nito. And then, measure the angle from the positive x-axis kasi yun yung default natin, more or less, pagdating dito sa engineering, especially pag nagmamoment tayo. We treat yung counterclockwise as positive, clockwise as negative. Anyway, that's a different topic naman dun eh. And then of course, pwede natin ito i-convert into Cartesian Vector Notation by summing rin naman accordingly yung per component niya. We can convert them into yung Cartesian Vector Notation and just algebraically add them or subtract them depending on their sign. And we get yung final resultant force na form, which is this one. A better way to write this is sa previous class ko, you can actually tabulate them in one go. And then you can add all, you can write yung F1 muna, yung Cartesian vector notation niya, and then F2, and then yung F3, then you get yung resultant force. So if I were to do that, if I were to rewrite it, pwede ko rin isulat na ganito siya, F1 of x I plus F1 of y j. In written form, meron siyang sombrero by the way. And then in this case, dalawa lang naman yung dimensions na. So meron lang tayong I and j, wala pa tayong third dimension. Okay? Pero mamaya na yan. Ito yung F1, then yung F2 is simply, since nasa kabila siya, pwede itong F2xi, and then positive yung y natin, F2yj, and then F3. So, masan to? Positive yung x natin, and negative naman yung y natin. So, F3x I minus F3yj. No, take note, hindi ko pa i-include yung yung angle na. So, halimbawa, may angle yan. You just use yung appropriate trigonometric function to get yung respective F1 of x, 2x, 3x, or F1 of y, 2y, 3y. And then, pag inad mo siya, technically ganun rin naman to, pero to sum it all up, ito rin naman yun eh, F1, 2x, puro x values yan And then ito, F1, 2, 3, puro y naman yan So, makukuha rin natin same nito, yung final form niya. In this case, lagyan na natin ng arrow yan. And then, FR. Usually, hiniwalay ko yan para lang ma-distinguish. And then, plus FR. Y. Okay. Usually, nalagay mo kung either newtons, kung yung SI tayo, or pounds. Pound force pag English yung ginamit. Okay? Sige. Para mas maintindihan natin to, let's try solving a problem lang naman dito. So, BND, alam niyo na kung paano i-solve to, pero for CNA, this is how we did it. Okay, naka-upload naman yung solutions ko, pero you can follow me step by step naman dito. So pagdating dito, we have example 2.6 from page 37. So meron tayong link. The link below is subjected to two forces. Meron tayong F1 at 600 and F2 at 400. Projected with their respective angles sa kanilang axis. In this case, F1 is projected from the meron tayong force na 600 newtons, 30 degrees from the x-axis, and then 400 newtons naman, 45 degrees from the positive y-axis. Kailangan sa atin, determine the magnitude and direction of the resultant force. And then after nun, we should express daw yung resultant force natin in Cartesian vector form. Okay, so madali lang yan. Kasi alam natin kung paano kunin yung magnitude and yung direction kasi simply ano lang naman yun di ba? Magnitude, simply square root lang naman ng summation ng FRX ng x component ng resultant force na yun and ng y component ng resultant force na yun. So all we have to do lang naman is get yung components ng F1 and F2 since given naman tayo ng angle and ng kanilang respective magnitude ng force. So, before anything else, you want to draw muna yun para ma-reflect nyo kung ano yung kailangan nyo hanapin. Just like I said, we draw mo yung diagram and then we reflect yung components. So, F1, meron siyang rectangular components, F1 of x, F1 of y, and then for F2, meron siyang F2y and F2x. And then, sa class ko sa BND, I think nagkamali ko one time, buti na lang 45 degrees siya, pero para hindi na rin kayo manito, mas magandang i-reflect nyo na rin kung nasa ano yung angle dito para at least alam nyo kung saan nakabase. 45 degrees. There we go. And then after nun, alam mo na kung saan yung position ng x and y components ng respective force vectors. Ang gagawin nyo na lang is solve for each x and y components via what? Trigonometry. Okay? First things first is reflect mo yung summation ng Rx, you solve it by components. So, sum mo na lahat ng x, sum mo na ng y. So, Fx, summation ng force x is simply nawawala yung mouse ko. Wait lang. The summation ng x forces will be dito. F1 of x mo is positive. Kaso F2x mo is negative. Just like so. So, naka-indicate na dyan. Yung scalar notation na kailangan natin include yung sign kaagad. And then, i-reflect na natin yung equivalent niya. So, we have yung 600 dito. So, 600 para makuha yung F1 of x is simply cosine. F1 of x is simply 600 cosine 30 degrees. Negative F2x mo dito, minus F2x mo dito, which is simply 400 sine 45. Kasi ito yun, dito sa taas. And yung ginamit ko yung 45 degree with respect to y-axis niya. So, yung x component niya, kung babaliktarin mo, is just simply yung sine 45 degrees. And you will get 236.773 newtons to the right. So, positive pa rin siya. Pero I would appreciate kung ilagay nyo lang yung sign. Okay rin yung arrow sa akin. Hindi na yung to the right, to the left. We try to be a bit more, efficient pagdating sa writing ng symbols natin or yung describing yung final answer natin. So, okay lang sa akin yung arrow para ma-indicate nyo kung positive or negative or just simply write positive or negative para mas madali. Okay? Kahit open and close parenthesis mo pa yan. Pero for now, okay na yung negative or positive para ma-indicate mo kung saan direction siya. Meron yung arrow niya. Then of course, next na naman yung y, you would do the same. In this case, pareho silang positive. So, 600 sine. So, F1, 600 sine 30 degrees. And then yung And yung F2 is simply 400 cosine. Yeah, 400 cosine 40 degrees. And when you add them together, you would get 582.843 newtons. So you can, since pataas siya, so that will be positive. Ang next mo naman gagawin dito is since meron ka na yung FRX mo and FRY, you can now simply get na yung magnitude using yung formula natin na yung force resultant magnitude mo is simply equal to the square root of the sums of the squares ng x and y components nila. Okay, so that means FR is equals to square root of force resultant x component squared plus force resultant y component squared. Substitute in values, you would get almost 629.10 newtons. Okay. And of course, from here, meron ka na yung x and y component ng force resultant natin. You can now simply get yung direction, which is simply the tangent inverse of the y component of your force resultant divided by its x component. You will get 67.9 degrees. This, of course, yung final task natin is to expressing resultant force. Now, you can do this two-way. I did here yung long way, which is simply getting yung Cartesian vector notation ng kada component, ng force 1 and ng force vector 2 ko. Or, you can simply get na yung FRX and FRY and just convert it to its Cartesian vector form notation. Pero let's try yung long way lang muna para makita yung step by step just in case hindi nyo pa alam. What if kasi nauna nyo na-solve is yung CVN eh. Itong components lang eh. So what I did dito is I did the long way. I got yung Cartesian vector notation ng force vector 1 and 2. Ang ganda dito, meron na tayong components ito. Alam natin kung ano sila using yung equations na ginamit natin kanina sa scalar notation. So we know na positive yung x natin. So yung I natin is positive. And yung F1x natin is 600 cosine 30 degrees. We know na positive rin yung y ng F1 natin kasi pataas siya. So we plus 600 sine 30 degrees J. So newtons. Ang ganda naka-express na ganito para indicating na this is just one unit. You're just expressing it in Cartesian vector form. Or in my opinion, para magmukha siyang algebraic equation lang, pero indicating na one unit siya. This is one force. Okay? Newtons. And then for F2, ganun rin. So, titignan mo yung components niya. Hey, nasa negative yung x component ng force vector 2 natin. So, magiging negative kaagad yan. Negative 400 sine 45 degrees. And then yung F2y naman natin, yung y component, positive. So, positive 400 sine 45 degrees J. Now, when you add them together algebraically, so add or subtract them together, you have, remember yung equation to, the sum of the resultant vector force is equal to the summation of its components F1 and F2, or yung summation or in this case, summation ng vector forces niya. And you would notice almost the same, 236.8, 582.8, pretty much the same. Or, simply, ito na lang gayahin mo since meron ka na yung FRX. Pag ito yung nakuha mo na kagad, you just simply add I lang dun and then add the appropriate signs lang dun. And that's it. You got your Cartesian vector notation na. Now, let me know if this lesson is going too fast, but this is a recorded video naman, so you can control yung modulation, yung pace ng video. So you can slow it down or fast track it if you want it. So yung next topic naman natin, we're gonna be dealing with 3D na. So all our lives, ideally, so madali kung puro 2D na lang, puro ganun lang, summation lang ng forces ng X and Y. Pero unfortunately, real life is 3-dimensional. At least to the extent of my knowledge, I don't know the 4th dimension eh. Anyway, ito yung typical XY plane mo. Pero right now, we will now be dealing with X, Y, and then yung resultant mo is occupying not just X dimension, Y dimension, but also yung 3rd dimension Z. Kaya pag we're solving volume, we always coin yung volume ng cube or yung parang is length times width times height. So, length times width times height. Ayan yung AZ mo. So, meron ka ng, for any vector force A, meron rin siyang X, Y. For 3 dimensions, meron rin siyang Z component. The A prime there is parang temporary placeholder to just in case given ka lang ng A and then an angle and you have to solve yung components ng ng XYZ components nito. Okay? You will see it later. So, ito yung representation niya from the book. So, occupying niya ng space na yan. Kung makikita mo in 3D space para malaman nyo it's in 3D space. Okay? Hindi na siya basta flat lang. So, meron na siyang essentially height and depth. Ito yung representation sa book nyo. And of course, para hindi nyo makalimutan, you can use yung hand nyo mismo, yung forearm nyo bilang yung y-axis, yung thumb nyo bilang yung z-axis, and then yung hands or knuckles nyo, yung iba sa inyo mas komportable din nakaturo yung index finger or if you want yung pinky para naka-rockstar symbol kayo. In this case, it's a lot more intuitive that way. Whichever is intuitive sa inyo kung ano yung XYZ values, XYZ axis nyo. Remember, lagi itong dito is positive. Pero going beyond that will be yung negative y na axis na yun. Going beyond this axis naman, that will be yung negative axis mo. So yung z naman, pag bumaba ka dito, that's negative z axis mo naman. Dito, you're positive pa. Okay? So, just like in 2D, 2 dimensions, yung 3D force vectors natin have rectangular components rin. And of course, you can also write them in Cartesian unit vectors. This time, meron tayong I, meron tayong J, and now, dadagdagan natin ng K para sa Z-axis natin. Recall that yung summation ng force vectors natin for 2 dimensions is just the summation ng force vector ng X and Y axis. Pero since we're considering 3 dimensions na, so vector A now is the vector sum of its rectangular components X, Y, and Z. Vector AX, vector AY, and vector AZ. Okay? Na pag i-convert mo naman sila into its Cartesian vectors, again, you just simply add yung k value natin sa k value natin sa AZ. So AX multiplied by I, AY multiplied by J, and AZ multiplied by K. Wherein hiniwalay lang natin hiniwalay na lang natin yung vector and yung unit vector. So inassign lang natin sa I, J, and K. They will again indicate kung positive, negative, or basically yung direction ng magnitudes ng AX, AY, and AZ respectively. Now, as for the magnitude naman dito, spoiler alert, sulat ko na lang rin. Kung ang magnitude ng isang vector sa kung sa 2D, kung meron tayong force vector A is simply the summation of the squares of its X and Y component. So, spoiler alert, pagdating sa 3D naman, technically, ganun rin. AX squared plus AY squared plus AZ squared. And I will show you why. So, ito yung breakdown niya. Sige, before anything else, bring ko lahat yung ink muna on the side. Okay, there we go. Para ma-breakdown, mapatunayan ko na ganun pa rin siya. In this case, dadagdag mo na ng AZ squared to get yung magnitude. We have a graph here. Hinati natin siya to 2 separate triangles. Para makuha natin yung A, di ba parang ito yung hypotenuse ng triangle lang naman. To get yung hypotenuse, di ba parang A squared is C squared equals to A squared plus B squared. In this case, we have yung A, ito yung AZ, and then yung A prime. All we have to do is just use the same principle of Pythagorean theorem to get this one. So, ayan, hinati ko na for you para may imagine nyo yung side. So, A is simply just the square root of the A prime squared plus AZ squared. Don't sweat ko ng definition ng A prime. It's just that yun yung, pag ginawa mo yung parallelogram law of additions mo, ito yung projected diagonal length niya. And then, whatever yung dulo nito, yun lang rin yung tapat siya dun sa tip. Yeah, tapat siya dun sa pinaka-tip ng vector A mo dyan. Now, from there, you can actually do the same thing pagdating dito sa gray area naman. So, that's a separate triangle. Ito yung AXI mo, AY, or basic AYJ. So, para makuha naman yung A prime dyan, you simply just the square root of AX squared and AY squared. So, pag sinubstitute mo yan, you would all get this one. Yung magnitude ng force vector A under 3D is square root ng ax squared, square root, and the sums ng ax squared, ay squared, and ng az squared. Daling tandaan. Now, we're talking about magnitude. Paano naman yung direction? For 3 dimensions naman, we have tinatawag natin coordinate direction angles. And yung label nila will be alpha, beta, and gamma. Madali lang. So, in direction ng 3D force vector, meaning per vector yun, depending kung ano yung given the problem, they have, you can indicate yung direction nila by using yung coordinate direction angles. So, let me explain yung relationship nila. Okay? So, we have yung graph dito. And so, they're measured between the vector tail, and the positive x-axis. So, vector na tama na. So, for vector A, so kunwari alpha, tatawid siya dito, all the way dun sa positive x-axis na yan. Beta naman, dito, dun sa positive y-axis. And dito naman yung gamma, all the way dun sa positive, say, axis niya. And note that, yung angles natin dito are greater than or equal to 0 degrees and less than or equal to 180 degrees. Kasi sometimes yung force vector natin lies mismo sa x and y axis, which makes computation a lot easier. Okay? So dito naman, just to simplify things, an easy way of obtaining this direction cosine is to form a unit vector UA in the direction of A. Ibig sabihin lang na parang representation, UA is simply the vector A, bold, may direction divided by its magnitude. And remember, yung vector A is a summation ng its x, y, and z components respectively. So, pwede natin equate yung equation just like so. And since pare-pareho naman yung denominator nila, pwede natin hiwalay yun. And i-assign lang natin yung unit vector nila to indicate kung saan direction sila, kung positive, negative ba sila. Okay? And this would indicate kung saan parts sila ng axis on their respective axis. In this case, nasa positive x-axis siya, nasa positive y-axis siya, nasa positive z-axis siya. And then, yung components ng unit vector represents the directions of cosine. So, yung, if you remember itong cosine alpha x over a, cosine beta ay over a, cosine gamma az over a, pwede mo substitute dito eh. So, yung unit vector natin can also be equated as cosine alpha times unit vector I, cosine plus cosine beta, unit vector j, plus cosine gamma, unit vector k. And this one, I'm not gonna differentiate na. Maybe we can use in trigonometric identities, pero the sums of the squares ng cosine squared alpha, cosine squared beta, and cosine squared gamma is equals to 1. Okay, that's easy naman to remember eh. So sometimes kasi may problem na, hey, you have everything na, all you have to do lang is identify this particular angle, but you're not given much of a given, but you're given all of the angles except one. You can actually use this to get yung specified angle mo. But be careful Just remember, check mo muna kung ano yung mga given mo to choose the right amount of, to choose the proper approach to a problem, okay? So halimbawa, if magnitude and direction of A is known, the vector can be expressed as such. So parang just to simplify lang dito, parang diniderive lang naman niya. You can also write this as such. Pwede mo express na yan. Cosine alpha A, cosine alpha I, cosine beta J, cosine gamma K. Ito rin yun. Pwede mo yung distribute. Pero very well, kung mapapansin nyo, A cosine alpha, parang ito lang nag-multiply dito. So technically, ito rin yung AX. X plus AY plus A. So, tinanggal lang natin yung unit vector I doon. Okay? Okay? So, ito yung vector form niya in the scalar notation form. Pag CVN, we just simply add lang yung I, J, K. Okay? Okay. You can also determine yung direction using yung two angles nun. Okay? In this case, nilabelan lang ng book as azimuth and traverse angle. I'm gonna skim through this lang kasi, again, yung formula naman ito is really dependent on paano nyo, yung configuration nyo per problem eh. Okay? So like I said, you should not memorize this equation. Rather, it is important to understand how the components were determined using trigonometry. So gamit tayo ng first example, which is closely related to this. We're given a force, we're given a force resultant vector, pero we're given two angles. Okay? So ito yung figure 2-30 ng page 48. Express the force F, 100 pounds, below as a Cartesian vector, where angles 60 degrees and 45 degrees are not coordinate direction angles. Again, they're not coordinate direction angles. They're just a reference kung gaano kalayo siya from the x-axis and gaano kalayo siya x and y-axis and gaano kalayo siya from the z-axis pataas. Okay? First thing you do here is you identify the XYZ components via the parallelogram law of addition. How do you apply that? You first draw muna or your own diagram. Yan, nag-timer lang. Umuha na akong kape. And then, you reflect na yung result. In this case, nilagay ko na ng force resultant, 100 pounds. And then, we're here to identify yung XYZ components niya. From here, we can get yung reference kung nasan yung XYZ component niya based kung paano nakaposition yung angles niya, no? So from here, we project yung X force niya dito and then yung Y component niya dito by just simply getting yung intersection na yan eh. So pwede kang lumagpas muna para ma-check yung drawing mo. And whatever intersecting point, this must be it. So for here, we form our first triangle. Yung X force natin and this yung FY component natin. Then of course, dito yung FZ. Pwede natin project dito rin eh. This is yung arbitrary F prime vector mo to determine yung y and x component. And of course, meron tayong fz. Okay? So just like what I did kung paano makuha yung magnitudes ng vector A kanina, hinimay ko siya by a triangle. So in this case, we have two triangles. We have yung slightly pink or yellow color dito. Maybe flesh. And then we have yung blue color dito. The next nating step dito, okay, we add lang yung angles para hindi tayo malito. Now, we simply can now solve yung respective components eh. Fz can be solved by getting yung 100 pounds times yung sine 60 degrees. F of x is, and then of course yung f prime dito, we can get it by simply getting yung multiplying 100 pounds by cosine 60 degrees. Then once you get yung f prime dito, you can get na following yung fy and fx. So, yep, we find components magnitude via trigonometry na yan. And we have them as such. So f prime dito is f cosine 60 degrees pounds equals to 50 pounds. And then from there, na-solve ko yung x and y components kasi dito sa baba, yung f prime mo dito is simply nataga sa hypotenuse mo eh. Okay? So you just follow that. F prime cosine 45, dito yon 45 degrees. That's your 35.355. And butin lang 45 degrees siya. Yung sine 45 niya is almost the same rin. Actually the same. And then, of course, Fz is 86.602 pound. Now, you have yung XYZ component nito. We now, ang kulang ko lang siguro dito pagdating sa components is, mas magandang i-indicate mo yung sign mo or kung nasaan yung arrows. Okay? So, for example, X, this is for sure on the positive X-axis. So, this is going to the right. In this case, para hindi tayo malito since we're doing 3D na, it's best na pare-parehos tayo dito. Mas maganda kung okay lang sana kung 2D eh. Okay lang sana kung 2D pero since 3D baka malito kayo. So in this case, lagyan nyo na kung positive, negative siya. So this is positive. Don't have to put it pag positive yan eh. Pero siguro indicate mo lang pag negative. In this case, si Fy naman, magpas na siya from the positive y-axis. So dito na yung negative y. Dito yung positive. So, alam natin na negative siya. Lagyan natin na negative sign dito. And z naman natin dito is relative sa taas pa rin naman. So, dito yung z, positive. Pag bumaba pa siya dito, ito yung z, negative. Okay? Same here. Ito yung positive x. Pag lumagpas pa dito sa axis na to, ito yung x, negative x axis niya. Okay? With this in mind, we can actually build na yung Cartesian vector form niya. Recall lang naman na summation of vector forces is that. Ayan yung forma niya. So, F is just simply yung 35, yung summation ng x forces niya. So, x lang naman is to. So, positive 35.355i. Alam natin negative to. So, negative 35.355i. Tapos, yung Z naman niya is 86.602. Okay? Now, technically, ito lang naman yung problem. Ito yung ask lang naman sa problem kasi we're being asked lang kung ano yung Cartesian vector niya eh. Pero, for our sake ng practice lang, we can go a step further. We can test it out kung tama ba to. Okay? To check, alam natin 100 pounds yung resultant. We just simply square the sum. We simply get the sum of the squares ng tatlong components na to. So, just one error here. This is supposedly plus negative 35 para mapakita pa rin na negative siya. Okay? Anyway, pag ni-square mo naman, magiging positive siya. So, pag nakuha mo yan and kinuha nyo yung square root nun, dapat almost 100 pounds rin siya. Or 99.99 pounds yan eh. Then from here, you can play, pwedeng minsan tanongin kayo sa problem na, what if, ano yung coordinate direction angle nyo? Ang maganda nito, alam nyo na yung resultant force, yung F. Then alam nyo rin yung magnitude niya. So all you have to do lang is just divide itong mga components into its magnitude, which is 100. So 35.355 divided by 100, negative 35.35 divided by 100, positive 86.602 divided by 100. Yan. And then, and you know na yung fx over f niya, yung fy over f nyo, and then yung fz over f is just simply equivalent dito sa yung coordinate direction angle formula natin, which is cosine alpha, fx over f, cosine beta, fy over f, and cosine gamma, fz over f. And you will get the following angles. Okay? Again, pero ito is just one force vector in 3 dimensions. What if there are more than one? What if sabihin natin meron tayong dalawa? Okay, for in this example, we have example 2.9, page 49. We have two forces act on the hook shown below. Specify the magnitude of force 2 and coordinate direction angle so that the resultant force Fr acts along the y-axis. Very important detail, acts along the y-axis and has a magnitude of 800 newtons. Then, medyo naghang lang saglit. There we go. So, very important details natin na although dito sa figure, we're given na yung F1 at 300 newtons with its respective coordinate direction angle. So let's just label it alpha 1. This is beta 1 and then this is gamma 1, referring to force vector 1. So sinabi niya pa dito, we have na yung resultant force Fr, which is acts along the y-axis daw. We can indicate yung una saan siya. So pwede natin mag-parallelogram tayo dito. Hanggang saan siya. May na gano'n. More or less mga dito siya. So naka-indicate na nandito na yung si force resultant. So ito si Fr mo. Ideally, mas magandang i-drawing mo siya ulit para makita mo siya for yourself eh. So we know na meron tayong given nun with its respective angles. And then of course, ang kailangan natin dito is yung magnitude ng F2. So yung force vector F2 natin yung unknown dito. Kailangan natin yung magnitude and yung coordinate direction angles niya. So we're here to look for alpha, beta, gamma, 2. Next. And then to solve it, we also know na yung summation ng force vector ng resultant force mo is a summation ng force vector 1 and 2 mo rin dito. So all we have to do lang is subtract force vector 1 sa Fr. So we proceed dito. A lot easier way to do this since meron ka nang given na coordinate. Iisipin mo, gagawin ko ba yung scalar notation or would it be best ko idiretso ko na lang to Cartesian Vector Notation para alam ko agad yung x, y, and z components ng F2 ko. So, dun papasok kung ano yung silbi ng Cartesian Vector Notation kasi you can actually get kaagad all three components at the same time by simply converting yun into equation and then and solving yung unknowns algebraically lang. So, plus minus lang tayo nun. Okay, let's get to it. So, find x, y, z components of f1, f2, and f3 via Cartesian notation. So, we reflect it just like so. So, meron tayong 300 dito. Ay, 600 tuloy. We have 800 newtons yan. There we go. Then from here, we get na yung, we can get kaagad yung Cartesian vector notation ng F1. So in formula, F1, force vector F1 is simply F1x times I, F1y times j, F1z equals k. And we know this because F1x, we know rin na may relationships na pagdating sa respective cosines nila. So this one is simply F1 cosine alpha times 300. So that's 300 cosine 45 degrees per y component. That will be 360 degrees. And then 300 cosine 120 degrees. Now, ang mali lang dito would be positive yung x, positive yung y. This time, kung makikita nyo, almost pababa yung z. So, dapat yung z natin dito, yung k natin dito is technically negative. Okay, which will, yeah, reflect dito. You can put it this way or simply just put na lang yung sign dito na negative 300 cosine 120 degrees. Okay, para lang ma-indicate kung nasang direction siya. So, nakuha ko dito is 212.13i plus 150j and then 150 degree k. And next naman dito is you'll get naman yung sa FR. Ang maganda dito, yung FR natin, yung force resultant natin, acts along the y-axis ng, which means 0 yung x component niya and 0 yung z component niya. So, we have lang yung 800j dito. By the way, kalimutan yung nangyari. Okay. Let me just erase that. Huwag kalimutan yung bracket dito. Ayan. So, yan. Then, indicate natin yung kanyang sign. Okay? So, all we have to do na lang dito is just get yung difference ng FR and ng FR and F1. Okay? We use yung formula na yun. And we substitute them accordingly. And then we get yung unknown ng F2. So, we just subtract them and we will get the following components ng force 2. So, FRI ko would be simply 800 newtons lang. So, 150. Eventually, you would get the following. F2x is negative 212.13, F2y is 650 newtons, and F2z is 150 newtons. Okay? And then from there, you can actually get na yung magnitude ng force 2, which is simply the square root of the square root and the sums of the squares ng components niya. Indicated just like so. So that will be 699.99 or 700 newtons. So yung next component, very similar dun sa first sample problem natin. We now can get na yung coordinate direction angles natin kasi una sa lahat, we now have yung magnitude, we now have yung x, y, z components nila. So we simply using coordinate direction angle formula to get yung respective angles ng force vector 2. And you'll get 108, 21.8, and 77.6 degrees. That's it. So, for any questions, feel free to email me or we can discuss this during class naman tomorrow or yung next meeting natin. Okay? So, yung next naman dito is yung position vectors. Ang tanong dito would be, what if we are not initially given angles or magnitudes but rather coordinates? Parang literal length ng gaano kahaba from the x-axis, gaano kahaba from the y-axis, and gaano kalayo from the z-axis. More intuitively, we are given coordinates how far A from B or how high point B from the ground. And let's take 3 coordinates x, y, z. comprise the sense and direction of the position vector R. Okay? In this case, papalitan lang natin yung usual vector labeling natin to R or R with an arrow. Yun yung position vector natin using actual distances with respect to the X and Y axis. So, nakalagay mo dito, position X, Y, Z axis. So, yeah, there we go. So, meron tayong X, Y. So, yan yung point niya relative sa X and Y, Z axis. Ganun pa rin. X, I, and then Y, J, and then Z, K. Now, you can also get nasaan yung sense of direction niya, usually given yung length nila by using in tip-to-tail method. So, you can also do it this way. From the point of origin, you extend yung X, and then yung Y, pwede mo siya i-project dito mula sa head ng X. Project mo yung tail ng Y, and then project mo outwards. And then dito mo na may project yung Z. Again, very important to when it comes to identifying yung components na yan. Ganyan, ganyan, and ganyan. Okay? So yung Cartesian vector form ng vector R is simply expressed as the vector R times X, which is basically length, usually yan. Pagdating sa problem, usually in expressing length, so meters, feet, inches, really depends kung ano notation nila. So times I, yung unit vector natin, plus Y times J plus Z times K. Instead of you're dealing forces dito, we're dealing actual measurements in length dito. So ito naman siya express ng book nyo, almost the same rin naman. This one is two vectors naman to. So you have yung x, y, z length components ng vector RA, and then yung x, y, z, b components ng vector R, ng position vector B. And yung R is yung force resultant vector nila. We simply get yung difference ng 2 points na yan eh. So we have yung solving R and expressing R, a vector RA and B in Cartesian vector form yields R is simply, magkaiba silang direction, RB, mas malaki yung magnitude, minus RA to get yung force resultant R. So in this case, yung vector RB is a summation ng all ng X, Y, Z component ng B minus yung X, Y, Z components ng A, which will yield you yung Cartesian vector notation using two position vectors. Okay? We will sometimes refer to this vector with two scripts, sometimes RAB, pero R will suffice rin eh. Okay? So ito yung final form niya. Yung vector, position vector R mo would be the difference ng XB minus XA. So yung difference ng respective XY components nila. Then I plus AYB minus YAJ plus ZB minus ZA, then K. Okay. Pero sometimes, meron tayong application dito. One peculiar problem we have here is the force vector directed along a line where the direction of a force is specified in 2 points through which yung line of action passes. Let's take the chain example in your book. The force passes through chord A to B and B. In addition, our vector R passes through the same line of action rin. And we can define this common direction by the unit vector U equals to position vector R divided by its magnitude. And we can extend that, and ito yung magiging equation niya. Maalala nyo, this is pretty much the same rin yung magnitude when we're talking forces, in terms of forces pagdating ng magnitude. So sa denominator mo na, it's simply the sums, the difference of its the difference and the squares of its x, y, z components, and then you simply add them and then get yung square root. So in this case, square root ng is x component, difference ng b and a is x component square, difference ng y and ng b and a y component square, and difference ng b and a z component square. So for the numerator naman, simply ito yung Cartesian vector notation with its appropriate signs. I, J, K lang, it just indicates kung positive or negative sila. Okay? So to establish yung XYZ axis mo, and form a position vector along the length, just remember this. Position vector R is equivalent to yung head, yung pinaka-head minus tail. So, what does that mean? Gonna show an example dito. Tulad kanina, say, wait lang. Gandang kita natin as an example. So, kanina, meron tayong, and then meron tayong, let's just use yun. Meron tayong position vector dito nakaganon. And then, now let's use yung previous slides example. Let's use yung red ink. Para malaman yung x component na yan, it's just simply this. So, merong particular distance yan. Say, nabihin natin 3 meters. Ito yung head. This is yung tail. So, ibig sabihin lang naman niya dito, from the point of origin, meaning from the head, nag-expand siya sa positive x-axis ng 3 meters. From the point of origin, meaning 0. So, ibig sabihin lang yan, kung gamitin natin itong example na to, head ko is 3 meters minus 0. Kung maalala natin, merong y component pa. So, project natin dito. Bam! Pwede natin ilatag yan. Bam! So, ito yung ito naman yung y. Yung ry. Okay? Ito yung rx. Ito yung ry. And kung mapinsan nyo, sabihin natin ito ay 4 meters. Okay? And kung ilalatag natin dito, it's still from the positive y-axis. So, 4 meters from the point of origin. So, 4 minus 0. This is not always the case, but in this particular example, ganon. And then from here, we project yung, this is yung RZ. P natin siya ay, sabihin natin 2 meters. In this case, from the point of origin pa rin, ginamit ko lang yung tip to tail method dito. 0 yung tail niya, head niya is 2 meters. So, gano'n siya tinaas. So, that will be 2 minus 0. And that represents yung Rx, Ry, Rz. Okay? One more concept. We have yung dot product. So, the dot product of vectors A and B is written as A dot P. Is defined as the product of the magnitudes ng A and B and the cosine of the angle between their tails. So, I think scenario we're in, you have two vectors, and may angle in between them, you know. So, ang kailangan nyo lang tandaan, ito lang yung derivation ng formula lang naman yan eh. Ito yung laws of operation ko, ano yung pwede. Pero kailangan nyo lang tandaan na pag mayroon kang ganitang angle, ang dot product ng dalawang vectors is equals to A and B magnitude times cosine theta. So, product of the magnitudes and cosine theta. Yun lang yan. Then, yung Cartesian vector ng ganitong dalawang vectors, okay? So, pag handwritten form, ganito siya. AB. So, A dot P. AB cosine theta. So, pwede rin siya isulat na pag ganito. Magiging AX, BX plus AY, BY, AZ, BZ. Okay? So, yung Cartesian vector form niya. Essentially, you would yield with this. Ito lang naman yung kanyang derivation. And then meron tayong application dito. So, yung dot product application. Wait a minute. So, ito lang pag may wait lang. Yeah, so your dot product application, meron kang angle formed between two vectors or intersecting lines. So pag may theta ka, it's equals to cosine inverse the vectors AB, product ng AB, dot product nun divided by their magnitudes, where theta is greater than equal to 0 degrees and less than equal to 180 degrees. So, kung mapapansin mo dito, when the dot product AB is positive, meaning theta mo is less than or equal to 0, greater than equal to 0 or less than equal to 90 degrees. Pag it's negative, it's your theta here is less than or equal to 90 degrees, or greater than or equal to 90 degrees, or less than or equal to 180 degrees. This happens lang naman pag kang perpendicular vectors lang naman rin eh. And it still is a dot product application kasi meron kang vectors and then two vectors and merong angle in between them eh. Okay, let's try to simplify lang yung position vector for you. Okay, so meron tayong sample problem dito. We express the position vector RAB. So RAB in Cartesian vector form, then determine its magnitude and coordinate direction angles. Okay, so we're applying a lot of concepts dito. So let's do it one by one. So instead of we're given force, instead of we're given angles, we're given yung distances relative to the XYZ axis, just like so. Okay, so we have 2 points dito. How do we do this? Normally, I would draw this muna, pero for simplicity's sake, i-drawing ko muna, kung ilalapat ko na lang dito sa diagram. In this case, we apply yung tip-to-tail method dito to determine ano yung mga XYZ components muna natin. For in this case, we have yung measurements naman dito. So, projecting from the positive to negative x-axis, we have yung Rx. And then we have yung Ry. And then from that point, alam natin na pataas nito is yung 3 meters, which is yung Rz. Okay, ulitin natin. Okay, hindi natin na-gets yun eh. So, yung given problem natin, meron ka agad siyang dimensions. Gaano kahaba siya from its relative x-axis. Yung point A natin is 2 meters away from the positive x-axis and 3 meters away from the negative 3 meters away from the negative y-axis. And then, yung point B naman natin is 3 meters away from the positive x-axis and 3 meters up sa z-axis natin. Okay? Yung 3 meters na yun, yung point na to is also 4 meters, yung point B is 4 meters away from the negative x-axis. So meaning yung point dito, aabot dapat tayo dito sa point na to. Hence, bakit yung Rx natin is from point here to there, and then extend natin here to there para makuha yung Ry, and then Rz, simply that. Okay. Now, nakuha na natin. Ideally, i-drawing nyo lang siya ulit para makita ko sa diagram nyo kung naintindihan nyo talaga siya. And then, it's best na hindi nyo dungisan mismo yung diagram kasi yun yung given problem nyo, di ba? So, ideally, you draw it first muna. So, after nun, you establish na yung x, y, z position vectors. If you recall, di ba, rx, ry, rz, isa lang naman yung formula. Head minus tail. So, we're talking about lang dimensions dito. So, in this case, ano yung head and ano yung tail ng rx? In this case, so for example sa Rx, yung head niya lumagpas na siya sa ito yung positive x-axis eh. Lumagpas na siya. And dito naka-indicate na 3 meters. So this must be negative 3. So head must be negative 3. And then yung tail ko is 3 meters from the origin pero nasa positive x-axis tayo. So meaning negative 3 minus positive 3 equals to negative 6 meters. So, we're talking displacement dito. Hence, kung tawag sa kanya, vector pa rin. Anyway, hindi lang sinabi ni Hibler yun. Pero anyway, kung titignan mo, teka, di ba parang displacement to? Yeah. So, in this case, tatawagin lang natin muna siyang position vectors. Okay? Kasi they are expressed in actual dimensions or yung dimensions or lengths relative to its axis. Okay, so kaya position vectors eh. In this case, nakuha na natin yung negative 6 meters. So we do the same thing with yung ry natin. In this case, what do you think yung ry natin? So nakaproject na dito. We had our work cut out na. So makikita mo dito from the point of origin from here. So that's, yung head niya must be 4 meters. Then down here, makikita mo, may 2 meters dito on the negative y-axis. So yung tail niya must be negative 2 meters. So meaning, 4 minus negative 2, yung ry natin, which is another 6 meters. And then for rz, simply, yung head niya is 3 meters from the point of origin. Yung project lang natin doon. And ito, 0 kasi nasa origin eh. Pag dumaan ng origin, 0 siya. So in this case, 3 minus 0 is 3 meters. Okay. So far, so good. Kung yan lang yung tanong sa problem, meron ka ng easy points. Okay? Ngayon, we now convert them into Cartesian vector form. And recall, yung Cartesian vector form is simply RAB, or position vector R, is X or Rx times I plus Ry times J, and then plus J times K. So mangyayari na, RAB is simply equals to negative 6I plus 6J plus 3K. It's okay na, pwede mo siyang isulat ng Rx na para malaman natin, ay, position vector din naman to or not. Position vector to. Okay? So in this case, nakuha mo kaagad yung Cartesian coordinate, nakuha mo kaagad yung Cartesian vector form or Cartesian vector notation ng position vector RAB. But di pa tayo tapos kasi kailangan daw natin hanapin yung coordinate direction angles. Eh ano yung kailangan natin doon? Meron tayong components pero mga vector to. Para malaman natin coordinate direction angles natin, kailangan natin yung magnitude ng RAB. How do we get that? Okay, so now, gagamitin natin yung Pythagorean theorem. Basically, we find yung magnitude via Pythagorean theorem lang naman. Remember yung formula na our position vector R is simply the sums of the squares ng Rx, basically square root, Rx squared plus Ry squared plus Rc squared. Essentially, ito lang yun. Essentially, ito lang yun. The same thing na ginawa na sa 3 dimensions. Pinakomplika lang kasi meron tayong head minus tail pa dun. Okay? So, wait lang. Actually, mas magandang balikan natin yun. So, eto yun. Okay. So, essentially, this is also, susulat ko to. Okay, susulat tayo. Susulatin ko ulit to. Essentially, ito yung R. Vector R in hidden form. Rxi at Ryj plus Rj k. Okay? And then, yung next slide nito, kasi meron siyang head to tail talaga. I-express natin lahat ulit. So, head to tail is simply yung Rx, Ry, Rz natin. And then ito is simply yung magnitude ng simply square root ng ito is simply Rx squared rin yan plus Ry squared plus Rz squared. Rin ito. Rin sila. Okay? Medyo pinakomplika lang ni Hibler. Hindi ko lang siya na-edit properly. So, nasaan na tayo? So, back to our problem. Okay, so nakuha na natin yung magnitude via Pythagorean theorem and yung resulting number nito is yung 9 meters. From there, we can get na yung solve for coordinate direction angle. And this is just a matter of formula na lang. Kasi we know na cosine alpha is simply RAB, Rx over RAB. So we simply get lang yung inverse ng mga yan, respectively sa alpha, beta, and gamma, and we will get the following angles. Okay? So, kung ito-drawing ko pala ito, okay? So, they're referring sa RAB, So, kung ito-drawing ko ulit to, kuha tayo to. Kuha ulit ako ng pen. Ibahin natin yung kulay. So, let's go black ulit. So, again, ulitin natin to. So, ito yung, okay, good. So, yan, and then, ganyan. Ito yung Z, Y, X. Ibahin natin yung kulay. Ibahin natin orange, okay? Or, yeah, actually red muna. So, ito yung position vector niya ulit, ganyan. Then, at a certain point dito. So, A and B, ano? So, yung tanong ng coordinate direction, it's referring to this, ah. So, para magets mo kung saan yun, gawa tayo ng kulay blue naman dito. Essentially, gagawa ka ng sarili mong XYZ axis dito eh. Then, kasi itong XYZ axis to is may silbi siya pagdating sa dimensions ng position vector. 2 meters, 3 meters eh. Pero itong mga angles ito, you're referring it from yung coordinate direction angles from a particular XYZ axis rin eh. So from here, kung mapapansin mo, tama ba na 131.81 yan? Technically, yes, kasi ito yung x. And then, kung may measure mo from the tail ng vector, here. So, yan yung alpha. Malayo. And then, ito yung extended version nito. Ito yung y-axis is 48.19. Ito yung in-between dito. Ito yung beta. Then, kung makikita mo dito, this is yung 70.53 degrees. Hindi malayo kasi ito yung gamma. Kaya kung hindi nyo na-gets yan, okay lang, pwede ko i-explain sa inyo rin doon. Again, when you're trying to solve for coordinate direction angles, again, medyo iba nyo yung XYZ axis nyo relative dun sa origin point. So in this case, ang origin point nito, sabi niya RAB. So ang origin mo dito would be, ng position vector RAB would be yung point A. Yung XYZ axis lang naman dito, ginamit siya for reference ng lengths relative to our axis. So 2 meters from the x-axis, 3 meters from the negative y-axis, 4 meters from the positive x-axis, 3 meters from the positive y-axis. Okay? Pero para makuha mo yung Rx, Ry, and Rz. But when you're talking about yung coordinate direction angles na, you're referring na to the actual position vector itong buong to. So, yan, yung AB. Okay? So let's try one more problem and then ito na yung magiging end ng lesson. So in this case naman, we're given a force. Okay? And we're here to determine yung angle theta between force and line AO. Okay? This is dot, by the way. Hindi siya dot. It's dot. So, yeah, this is ibigay ko na lang yung kulay. Ayaw niya, di ba? So, yeah. So, again, typo lang ako. This is dot. Okay, that product variable by components. So, if I'm gonna position vector is one of those concepts na it's better shown than explained eh. So, ito yung concept ng dot products better shown than explained. So, for example, we have a problem here. Determine the angle. Wait lang. Let's go with red ulit. Determine the angle between the force, this one, expressing Cartesian vector notation, and sometimes it does happen that, and yung line AO. So, we're given two forces dito. Two vectors. So we have yung, I believe wala akong nakasagot. We're given two vectors. One is yung force expressed in Cartesian vector notation and another one along a chord dito, along the line. So meron tayong force and then meron rin tayong position vector. In this case, let's call it position vector AO. Okay? And then nakasulat dito yung naka-indicate dito yung kanyang reference length from its respective axis. Okay, so what do we do first? Okay, we know na the dot product, just to recall lang, the dot product ng variables and magnitude is, so dalawang force vector is equal to the product of its magnitude and cosine theta. Alam natin yun. And then yung variable components niya, so yung other equation natin doon, is also equal to its to the product of its x and y components, x, y, z components respectively. Maalala niyo yung maalala niyo yung previous yung dot product na lesson doon. Basically, dalawang vector AB, whether force ba yan or position vector, is equal to the products ng magnitude and cosine theta. And essentially, vectors AB, yung dot product nila, that is also equal to the sums of the products ng respective x, y, z components nila. So, in this case, sisimula ko lang ax, bx plus ay, by plus az, bz. It's just so happen lang na binigyan tayo ng force and ng position vector kasi parehas silang vectors nga naman. Okay? And then for us to find yung kailangan natin, yung angle in between, we combine equations 1 and 2 lang naman. So in short, alam natin yung end product. Ito yung type ng situation na, okay, so meron tayong intimidating force given and a line vector and a position vector na hindi ko muna kabisado. Pero I do know yung formula ng dot product, which is ito. So, quick ko lang yan. So in this case, force vector F, position vector AO equals also to magnitude F times magnitude magnitude ng RAO, cosine theta. So equation 1 yun. And then ito yung respective variable by components naman niya. Okay? So all we have to do na lang is determine yung magnitudes ng mga to. Okay? So I guess since fresh pa yung position vector, we can get that first. Wait lang. So kunin natin yung RAOX kasi meron naman tayong given dimensions dito. 2 meters, 2 meters, 1 meter. So you think, so meron tayong 1 meter dito sa positive x-axis, 2 meters dito, so nakatapat siya sa negative y-axis, and 2 meters dito naman. So far so good, nasa positive z-axis tayo. So ROX, so alam natin papunta siya doon, so merong 1 meter, so ang head natin is 0, technically ang tail natin is 1 meter, and then yung RY lang. ROY naman natin is from here, so from here to here, so magiging 0 minus 2 meters naman. Minus negative 2 meters. And then ROZ, pababa naman tayo. So magiging, head natin is 0 minus 2 meters. Tingnan natin kung tama ako. Okay. Since given na yung force natin dito, I guess mas magandang unahin na natin yung force muna and we can actually get yung components na to. We need F, position vector, and position vector AO. With vector F, we can get that now with negative 6, 9, and 3. And kailangan natin yung respective x, y, z components yan. Luckily, we have na yung components niya. All we need to do na lang is yung magnitude niya. And we can get F by yung Pythagorean theorem. And using yung components, negative 6 kilonewton squared, 9 kilonewton squared, 3 kilonewton squared. F equals to 3 square root ng square root of 14 kilonewton or 11.225 kilonewtons. So that's 1. Tapos, we can also get yung position vector R by getting yung XYZ components via Pythagorean theorem. So, just like so. So, tulad ng sinabi ko kanina, tama naman tayo. So, yung head natin, since sa point of origin tayo, papunta tayo sa origin O. Okay? So, magiging 0. So, from 1 meter na head to going to its origin, dun sa endpoint niya, head ko is 0, tail ko is -1. So, 1 meter. So, 0 minus 1 is -1 meter. So, yun yung x component natin. Okay? Pagdating naman sa RAY, so from here, meron tayong 2 meters sa negative y-axis tayo. That will be, and then papas tayo sa origin, that will be 0 minus -2 meters. So, that's 2 meters. And then meron tayong z naman from here to here. So meron tayong dito yung head natin is 0 meters pero yung total height nito is 2 meters. So 0 minus 2 meters is -2 meters. So nakuha na natin lahat yun. And RAO is simply yung components na to, squares ng sums nito. -1 squared plus 2 squared plus -2 squared. Then kunin mo yung square root, that will be 3 meters. Okay. Just in case kung kailangan kunin yung vector notation, ito lang naman siya, -1i plus 2j, -2k meters. Okay? So from here, we have yung position vector, we have yung position vector force. We have yung position vector, which is ito, in expressing Cartesian vector notation. We have yung force vector, express yung Cartesian vector notation. Ito. We have yung components nila. All we have to do na lang is substitute accordingly. So, equate 1 and 2. And then, get the cosine inverse nito, which you will get 57.68.88 degrees. Okay? Now, it seems very complicated yung problem, pero if you solve it really by parts and identifying which is the easiest to solve muna, so yun yung path to least resistance, yun yung simulan mo. So kanina dito, well, I wasn't looking kasi dun sa guide screen ko. So kanina, nilabel ko kaagad yung ROAX ko, ROY ko. So hence, buti na lang tama yung ano natin. So just a point of ano lang, just a tip lang siguro. So always indicate kung saan papunta yung RAO nyo eh. And then from there, naka-indicate sa diagram kung ano yung point of origin eh. From the previous slide, naka-indicate kung nasaan rin yung point of origin mo eh. So here, yung point of origin mo is somewhere here. And then ito yung mga dimensions nila, RX, Y, Z. And then pag kukunin mo yung coordinate direction angle, so sabi niya is coordinate direction angle ng RAB, you go back to sa start. So point A mo, gagawa ka ng panibagong XYZ din, and then yung ilatag mo yung alpha, beta, and gamma mo. And then just to see if it makes sense yung mga values na to. Now, doon naman sa, again, dito naman, so mapapansin kaya 0, -1 kasi alam natin from here, meron na siyang magnitude na 1 meter eh. Pero babalik tayo sa point of origin niya dito. Kataon lang na O lang yan ah. Okay? So, usually given naman to. So, pag pabalik kang ganon, so you go from 1 to 0. So, head to tail, head minus tail. So, 0 minus +1 kasi na positive x-axis ka. So, in this case, 0 minus 1 meter is -1. ROI, yung RY mo naman dito, mapapansin mo at this level, kung ipoproject mo, is yung tail niya is 2 meters. Pero papunta yung direction towards a point of origin. So 0 meters yun. Okay? So in this case, nasa negative y-axis siya. So obviously -2 yun. So head minus tail is 0 minus -2 is +2 meters. Okay, baka malito lang doon. Yung force vector, madali na lang kasi you've been doing a lot of practice dito. Baka yung position vector is yung di lang kayo familiar. Okay, ganoon rin with the Z. Meron na siyang magnitude dito, 2 meters. Pero makita mo, pababa siya towards O. Towards O. So, in this case, yung head ko is 0, pero yung tail ko is +2 meters. That would mean head minus tail, 0 minus +2 is equals to -2 meters. And that concludes yung lesson ng force vector. Naka-upload na yung modules na to. I even included yung updated force vector lecture, correcting lang some of the positive and negative signs doon, pero ultimately nakuha ko pa rin yung tamang sagot. It's just that I was more focused on copy and pasting yung equations eh. In the following modules naman, you will be seeing a lot of handwritten ones. just let me know lang na if they are legible enough for you guys to read, you know. I've also uploaded yung problem sets with selected solutions naman. Selected, ang appropriate term yata siguro doon with selected problems with solutions, you know. Either way, the samples should give you enough clue and practice time to answer yung mga walang solution doon. Okay? And think of it as a practice na lang rin kasi yung susunod na topic dito is sobrang dali kasi you're practically transposing yung same concept pero we're just talking about yung equilibrium of particle. Kumbaga doon tayo magsisimula magsa-summation equals to 0. Dito nagsa-summation lang tayo ng x and y and z axis natin pagdating sa 3 dimensions eh. Okay? If you have further questions, let's just talk about it na lang sa class. And then with that, ending the recording.